Learning objective 2. To write sentences, word equations, and skeletal equations to describe a chemical reaction. So these are just ways in which we can describe a chemical reaction. So sentence, general form for a sentence is reactant 2 reacts with reactant 2 to form product 1 and product 2 and product 3, or product 1, product 2, and product 3. So that is your general form for writing a sentence. Now, we need to, when we are describing a reaction, be sure to include the state of matter to each substance, which is considered either a reactant or a product. We've been over the symbols already in Unit 3. I did a brief overview of those, but they are as follows. So a parentheses, S is solid, parentheses, L is liquid, parentheses, G is gas, and a parentheses AQ is aqueous, which aqueous substances are dissolved in water. We could also call these solutions. So, general form. Reactant 1 reacts with reactant 2 to form product 1, product 2, so forth and so on. So let's look at an example. So I'm going to write a sentence. So I'm writing a sentence from the following equation. NaCl, AQ, plus AgNO3, AQ. Arrow, NaNO3, AQ, plus AgCl, S. Okay, so first thing is that this is aqueous, right? So this is, we could say that all of the ones that are aqueous, we can call them solutions, right? Solutions. So NaCl, solution. AgNO3, solution. Now, this is where last unit becomes in handy because of the fact that we are taking these guys and we're writing the name of them. So the chemical name, right? So Na, I don't know how to find these. Na, okay, I'm going to go, Na is right here in this region right here, right? So I can highlight it. It's right there, right? Na is sodium, okay? So then sodium, Cl, right? We know this one. You should know this one. To my periodic table. Oh, that's chlorine. Well, actually, it changes its ending. It's chloride, right? So going back over here. So I know that this is sodium chloride solution because it's aqueous. This little plus sign reads reacts with. So sodium chloride solution reacts with Ag. So if you don't know what this is, it is silver. NO3. NO3 is going to be on the back of your periodic table. NO3 is nitrate. So it's silver nitrate. Solution. You could also say the solutions of sodium chloride and silver nitrate react to form. It's however you really want to say this. I'm not going to be that picky with it, right? Just know that I'm using the solution is going in for the AQ, right? So the aqueous. So sodium chloride solution reacts with silver nitrate solution. So it reacts with to form So notice kind of what's happening here. The sodium is kind of sodium and silver are replacing each other. So I've got sodium nitrate, silver chloride, right? Names aren't really changing that much, right? So it's forming a precipitate of silver chloride. So precipitate is telling me that it is a solid, okay? And a solution of sodium nitrate. Okay, that's my sentence. Sodium chloride solution reacts with silver nitrate solution to form the precipitate, silver chloride, in a solution of sodium nitrate. That's it. Okay. So the second way that we can describe a reaction is by word equations. So word equations, we're pulling out the names of the reactants and the products. We use plus signs, arrows, and symbols for the states of matter. There's a couple of different types of arrows that we can use. So if I have an arrow and I have a little delta sign on top of it, right? This means that heat is added. If I have an arrow that says something on top, so like electricity, that means that electricity is added. If I have an arrow and it's got like some chemical symbol or chemical formula on the top of it, so like PT. PT stands for platinum. This means that a catalyst was used. So I have a platinum catalyst here. If I see an arrow that is going both forward and backwards, this is equilibrium. Most reactions, you wouldn't really realize it, but they are equilibriums. So most reactions are equilibriums. But we don't talk about equilibrium in this class. So you can kind of ignore that. So, for example, we're writing a word equation from the following sentence. So the sentence is a solution of copper 2 chloride reacts with aluminum metal to form copper metal in aluminum chloride solution. So all we're doing is pulling out the reactants and the products, right? So here's a reactant, and this is its state, right? So it's a solution. That means it's aqueous, right? And reacts with is going to be the plus sign, right? This is another product, aluminum. Well, metal, so metal is going to be the solid, right? Solid form. And then we can have copper. So it's forming. So to form is going to be my arrow. And then I'm going to have copper, right? So copper. And then it's a metal, right? So this goes here. So this is going to be a solid again, okay? And then and is the plus sign, right? So and aluminum chloride, which is my other product, right? And then I have the solution. So this means it's also aqueous, right? So that's all you're doing. You're pulling all that stuff out. So my answer here would be copper 2 chloride, aqueous, AQ, plus aluminum, S for solid, arrow yields copper, solid, S plus aluminum chloride, AQ. That's it. Okay. The third way that we can describe an equation is through a reaction is a skeletal equation. Now, even if you're not even describing it as a word equation or a sentence or anything like that, you are still going to have to go through the skeletal equation before you get to a balanced equation, okay? So this is the step you need to perform before balancing an equation. This uses symbols and formulas for the substances. Substances, again, are reactants or products, okay? This is an unbalanced equation, so it's not balanced, okay? You don't have to worry about balancing it. Unbalanced. This is the only time that we can write the subscripts of the compounds. Okay, so when you are writing a skeletal equation, what you are doing is writing the formulas for the compounds that are reacting, or the symbols for the elements reacting. That is all you need to do. You do not need to actually balance the equation, okay? Unless I tell you you need to balance the equation. In that case, then you're going to have to go through the skeletal equation and then balance it, okay? So just remember, ionic compounds, when we write their subscripts, we are crisscrossing their charges, or their absolute value of their charge, okay? So let's look at an example of this, right? So this example says, write the skeletal equation from the following word equation. So we are given the word equation, right? So magnesium. Well, I can't remember what magnesium is. Oh no. So I'm going to go to my periodic table. It's my trusty best thing ever, right? It's the best thing ever. And I'm going to look for magnesium. Okay, there's helium, there's lithium, beryllium, sodium. There's magnesium right there, right? Okay, so I've got magnesium. Its symbol is Mg, so capital M, lowercase g. So I'm going to go back over here, and I'm going to write for magnesium, Mg. Now, I don't want to drop my state of matter, so I'm going to still write the state in there. It's a solid form, magnesium metal, right? Plus hydrochloric acid. That's an intense one, right? So acid, AQ, right? Acids are always aqueous. Well, if I have acid, right? Acid is H plus, right? So it's +1. Hydrochloric. So I know that the acid name is always based on the anion that I've been given. So hydro is a prefix. And if I have the hydro, then my ending is IDE. So this is chloride. So the other way that I could write this is hydrogen chloride, right? But because it's aqueous, it's the acid. So chloride, I have no idea what chloride is. So I'm going to go back to my trusty periodic table. I know that my IDEs come from over here. So like my suffix, IDE, are going to come from over here. Not to mention, hydrogen's a cation, right? I've got to have an anion that goes with the cation. So my anion has to be chloride. So chlorine, right? So this guy right here. So Cl. Cl is in group 17. It has a -1 charge on it, okay? So I can come back over here. And I know that this is Cl -1, right? So they kind of cancel each other out. So this is HCl, and it's also aqueous, right? So now my arrow. Now I see over here, so like I'm going to go ahead and see over here. I already have a compound that's forming between magnesium and chloride. So I'm going to go ahead right here and write the charge for magnesium. So that way I can just go ahead and take magnesium and cross it with chlorine. And then that way I can have my formula for magnesium chloride pretty easily. Okay. So my next thing that forms is magnesium chloride. So Mg. Well, magnesium has a 2+ charge. The reason it's got a 2+ charge, again, is because it's in group 2. So group 2 all have a 2+ charge. Group 1 all has a +1 charge, except for hydrogen can be plus or minus 1, right? We've done all this before, multiple times, okay? So because magnesium has a 2 and Cl has a 1, I have to cross those down. So it's MgCl2. This is aqueous plus hydrogen. Well, I know hydrogen is H, right? This is where it's going to become important for you to remember the Magnificent Seven, right? So Magnificent Seven are the 7 elements that are diatomic. They have 2 atoms bound together. They form a 7 on the periodic table, right? You guys have to remember this, right? They form a 7 on the periodic table. And that 7 is nitrogen, oxygen, fluorine, and then chlorine, bromine, and iodine. That's 6. Wait a minute. But you said there was 7. The 7th one is hydrogen. So whenever these guys are by themselves, they are always 2. So go back over here. If I just write H, that's not right. It has to be H2 because hydrogen by itself is H2. And that's a gas. That is a skeletal equation. Now notice, I don't have the same number of chlorines. Here is here. That's okay. It's okay. I don't have to have them the same for a skeletal equation. When we balance an equation, that's going to be a little different because we do want them to be the same. Okay? So this is learning objective 2, to write sentences, word equations, and skeletal equations to describe a chemical reaction. So again, we can write a sentence. We can write a word equation, right? And then we could also write a skeletal equation. Okay? So that is learning objective 2.